All right, section 7.4 is about arc length and surface area. What's arc length? The length of a curve, that's right. So if I have some function f of x that looks like this, this is my function f of x, and I'm starting here, this is x equals a, and I'm ending there, that's x equals b. What I mean by arc length is, if you were to walk along the curve, how far would you walk? What would your linear distance be? That's what we mean by arc length, the length of the curve. How do you do that?
You can find the measure, you can find the middle point, find the measure of each individual arc.
Okay, so maybe if I could find the middle point,
Which would be at C, which would just,
somewhere C in the middle, right?
yeah.
Depending on the curve, maybe there's a formula for finding the area of that arc, I don't know. And maybe there's a formula for finding the area of that arc, I don't know. The only formulas that I know for arc length, the arc has to be a circle.
And we don't know.
And we don't know if this is like half a circle and then another half of a circle. We don't know that. It's probably not. So here's what we're going to do. We're going to take this arc and we're going to split it into a bunch of different pieces. I don't know how many pieces I just made. I made a bunch of different pieces. And then what we're going to do is we're going to connect the two pieces with a nice straight line, and we'll find the length of that line. And we'll find the length of all the lines. So here I'd have 1, 2, 3, 4, 5, 6, 7, 8, 9. I would find the length of all 9 lines, and then I would add them up. Now, would that give me the exact arc length?
No.
No, but would it be pretty close?
Yes.
Yes. And if I wanted to get a better answer, how would I get a better answer? Build more segments. And how would I get the exact answer? Build an infinite number of segments. All right. So, if I call this point right here, I'm going to call this one x1, y1. And I'm going to call this point over here x2, y2. How do I find the length of that nice straight line? You use the distance formula. That's correct. So the length of that nice straight line is, distance is, what's the distance formula? Square root of x2 minus x1 squared plus y2 minus y1 squared. Very good. So that's how I would find the distance of one little piece. All right, I'm going to do a little fiddling with this here. I'm going to write this as the square root of delta x squared plus delta y squared. So what did I do there?
It's the same thing.
It's the same thing. x2 minus x1, we've called that change in x. y2 minus y1, that's change in y. So I just changed symbols there. Okay? Then I'm going to write this way. This is, how do I want to do this? Square root of delta x squared plus delta x squared times delta y squared divided by delta x squared. It's the same thing. Very good. Why is that the same thing?
Oh, because the delta x squared is canceled.
I multiplied by delta x squared over delta x squared. Delta x squared over delta x squared is 1. Okay? So this is the same as the square root of delta x squared times 1 plus delta y squared over delta x squared. What did I do that time? I pulled out the delta x squared. I had a delta x squared there, and I had a delta x squared there. That was my common term. I simply factored it out. So I factored out the delta x squared. Delta x squared times 1 gives me the delta x squared back. Delta x squared times that fraction gives me back what I had there. All right. Now I'm going to write this as the square root of 1 plus delta y squared over delta x squared times delta x, where that delta x is now outside of the square root.
You can factor out or you can square it. It can just be
That's right. The square root of delta x squared is delta x, and I chose to put it on the end. Why did I choose to put it on the end? Just because. I have a good reason, actually, but I did put it on the end. All right. So, now let me ask you a question. What's delta y over delta x? Slope of what? Slope of which line? That little line that I drew. Back up there. What's the name of the line when we connect 2 points? No, that's the secant line. Delta y over delta x, that's a fancy way of saying the slope of the secant line, isn't it? However, we had ourselves a theorem a while ago that said if you have the slope of the secant line and your function is continuous, somewhere in between the slope of the secant line is exactly equal to the slope of the tangent line. What was the name of that theorem? Not Rolle's.
the other one.
It was the other one.
Oh,
That was the mean value theorem. The mean value theorem says somewhere in between the slope of the tangent line and the slope of the secant line are exactly the same. So I don't know where that point is, but I'm going to pick it. So instead of writing delta y over delta x, I'm going to write what would the slope of the secant line be? What would the slope of the tangent line be? The derivative. So instead of delta y over delta x, I'm going to write f prime. But these are both squared, so I'm going to have f prime squared. So this is, for some value in between, I don't know where the value is, I really don't care. This is the same as, by the mean value theorem, 1 plus f prime of x squared. And delta x, that's another symbol for dx. That's why I put that delta x on the end. Can I move it up a little bit so you can see it? Sure.
so then would you also include integral from however many lines?
So that's the length for finding one little strip, isn't it? Now I want to find all the lengths and add them up. What's my symbol for find all the lengths, building an infinite number of little strips, and add them all up? You just said it? Integral. So our formula for arc length. There it is. It's the integral from a to b of the square root of 1 plus the derivative squared dx. There's the formula for arc length that we're going to use.
And that's the derivative of the function. Right?
That'll be the derivative of the function, whichever function you're given. Correct. Questions about that? All right, so I'm going to pick a function here. I'm going to use one out of the book. F of x is 3/2 x to the 2/3 and we're given the interval from 0 to 1. I said 3/2, but I wrote 2/3. Should be 3/2. So there's our function. Our function is f of x equals 3/2 x to the 2/3, and the interval we're given is 0 to 1. We want to know the arc length. What's that? How about 1 to 8? I can't read my own writing. It's right there in front of me. 1 to 8. That's what it says. 1 to 8. All right. So our formula is for arc length. The integral from 1 to 8 of the square root of 1 plus the derivative squared dx. So it looks pretty simple, right? All I need to do is find the derivative, square it, plug it into that formula, and work it all out.
Doesn't sound
It sounds easy.
so
What is it actually easy? Well, let's see. What's the derivative? F prime of x is? X to the 3 halves, not x to the 3 halves. X to the negative 1/3. Because you bring the 2/3 down, 3 halves times 2/3 is 1. You subtract 1 from your power. So the derivative squared is x to the how do you take x to the negative 1/3 and square it? You multiply your exponents. So it's x to the negative 2/3.
We can have negative exponent, right? So we'll have to be 1 over x to 2/3.
Sure. 1 over x to the 2/3. That's fine. All right, so our answer becomes the integral from 1 to 8 of the square root of 1 plus 1 over x to the 2/3 dx. Now's where the fun begins.
Now we did that. Add them all up.
Well, the integral says add them all up. The integral says we're building an infinite number of them, we're adding them all up. The fun is, how do we find the antiderivative of this function? U substitution. Okay, what's U going to be? Okay, that would be a reasonable guess. U should be 1 plus x to the negative 2/3.
Should it just be 1 over x to the 2/3 because it's 1 root 1 1?
That is true, but because of this plus sign, I can't split this into root 1 and root...
Could we do the whole conjugate thing? Clear it up.
I could, but that's going to make more fractions because I got to multiply top and bottom. So it seems like, this isn't going to work though, it seems like U should be the thing under the square root. Why isn't that going to work? What happens when you take the derivative? You're going to have negative 2/3 x to the negative 5/3 dx. Do I have an x to the negative 5/3 out here to match with this x to the negative 5/3? No, I do not. So it doesn't look like U substitution works.
So is that it?
Oh no. I told you this is where the fun begins. Here's what we're going to do. We're going to use U substitution, but we got to do a few clever steps before we can use U substitution. All right, so here's what we're going to do. We're going to write this as the integral from 1 to 8 of the square root of x to the 2/3 over x to the 2/3 plus 1 over x to the 2/3.
Are we essentially working backwards from the theorem?
From which theorem?
From the one that you just did?
No, not really.
Not really.
No. But tell me, what did I just do?
You just made
I wrote 1 in a funny way. Why did I write 1 that way? Now I have the common denominator. I can add them together. Okay. So this becomes the integral from 1 to 8 of the square root of x to the 2/3 plus 1 divided by x to the 2/3 dx. That whole thing's in the square root. Okay, so I can write that as the integral from 1 to 8. What I'm going to do is I'm going to do the square root of the numerator. I can't do much with that because it's connected with a plus, x to the 2/3 plus 1. But now I'm going to do the square root of the denominator. What's the square root of x to the 2/3? X to the 1/3. Excellent. Why is it x to the 1/3? Correct. X to the 2/3, this 2 means you're squaring something. And then if we're square rooting it, the square and the square root are going to eliminate each other. So all we're going to be left with is the x to the 1/3 dx. Now we're ready for U substitution. So what should U be? X to the 2/3 plus 1. And then du is 2/3 x to the, nope, subtract 1 from your power. You're doing derivatives, not integrals. negative 1/3 dx. Do I have an x to the negative 1/3 to match with that x to the negative 1/3 in my du statement? Yes, there it is right there. An x to the 1/3 on bottom is the same as an x to the negative 1/3. Except I got the little problem with this 2/3. So what am I going to have to do with this 2/3? I'm going to have to put a 2/3 here. So to balance it out, I need a 3/2 out there. All right, so we get 3/2. The integral of u to the 1/2 du, because this x to the 2/3 plus 1, that became u, and I wrote it with a power, x to u to the 1/2. And this x to the 1/3 dx, with the x to the 1/3 on bottom, was this part. How about my numbers now? How about what happens when x is 1? What's 1 to the 2/3? 1 plus 1 is 2. And up on top, when x is 8, how much is 8 to the 2/3? Close? 4, because this means cube root of 8, which is 2. 2 squared is 4. 4 plus 1 is 5. All right, finally we're in good shape. Now we have something we can do. Final answer looks like you've got 3/2.
You wrote 5.
No, because it's 4 plus 1.
Oh.
4 plus 1. We have the 3/2. What's the antiderivative of u to the 1/2? No, that's derivative. Antiderivative. U to the, add 1 to your power. 3/2, divide by your new power. Same as multiplying by 2/3. Flip and multiply. Well, that's fairly nice because those reduce. So my final answer is 5 to the 3/2 minus 2 to the 3/2. If I wanted to, I could grab my calculator and get a little decimal.
How are we going to know what we need to do to get it so it works with these substitutions? Is that going to happen like every time? Or?
All right, well, you might have wondered right from the beginning, why would I start with an example like this? Why wouldn't I start with an easy thing like x squared?
Because x squared is probably harder.
X squared is actually harder. Because for x squared, no matter what you do, u substitution will not work. Okay? So, the problems in the book are nicely rigged so that you can work this out, do some crazy algebra in the middle, and make u substitution work. The good news is, on your test, you won't have to do that. So here's what you're going to do on your test. Let's say I just gave you f of x equals x squared, which seems like it would be nice and simple. F of x equals x squared. And then I need an interval. Anybody got a nice interval?
0 to 6.
0 to 6. All right, here's what you're going to do. Your answer would be arc length is the integral from 0 to 6 of the square root of 1 plus the derivative squared dx. So what's the derivative this time? 2x. The derivative of x squared is 2x. So what's the derivative squared? 2x quantity squared, which would be 4x squared. So you're going to write the integral from 0 to 6 of the square root of 1 plus 4x squared dx. That integral can be evaluated. Next semester when you take Calc 2, Mr. Evans will teach you about integration by trig substitution. And that problem can be done using integration by trig substitution. But you're not going to have to do that on your test. What are you going to have to do on your test? Nope. You're going to grab your favorite calculator. And you're going to type that into your calculator and you're going to get me an approximation. So here's how I would do it on my calculator. There's multiple ways. I would turn my calculator on. I push the math button. And I go down, 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 down to FNINT, function integral. I hit enter. All right, so right now I have my calculator set up with the old system. So I'll show you what it looks like in the old system, and then I'll turn my calculator on to the new system, and I'll show you what it looks like if you have a newer calculator. So what you have to do is you have to type in your function. Our function is the square root of 1 plus 4x squared. Comma. Then you got to tell your calculator what your variable is. Not yet. Right now I have this parenthesis closing my square root. This parenthesis in front of the square root, I'll close it right at the very end. All right, so again, I think this is silly programming. You type in your square root of 1 plus 4x squared, comma, you need to tell the calculator what your variable is, but the calculator will only allow you to use one variable, which is the variable x. So I don't know why you got to tell it the variable is x, but that's the way it was programmed. Not my choice. Comma, 0, comma, 6. What are 0 and 6? My integral. Close that bracket. Although if you don't close the bracket, the calculator will not tell you error. I hit enter, and it gives me my answer. So I would write down 36.92, rounded off to 2 decimal places. If you have a newer calculator, it's actually much nicer. You go math, you go down to this FNINT thing, and it looks just like the integrals that you're used to seeing. So you put a 0 there, use the up arrow, put a 6 there, move over, do your square root of 1 plus 4x squared, move over, whoops, put your dx there. So the newer calculators are actually much, much nicer when it comes to printing things like this. It looks just like you write it on your paper, which is very, very nice. And, of course, it gives me the same answer.
So does this calculator allow you to use another variable?
I think you could use a different letter here. Let's just try it. Alpha B. I think I could use B as long as I put dB right there. Try it. It does allow me to use a different letter.
So in that case, can you just find, like, does that mean that the calculator can now do, like, multiple variable calculus? If you can use more than one variable, why can't it?
That's a good question.
Because then you could do, like,
I don't know. Let's find out. So if you're doing multiple variable calculus, then you need multiple integrals. So you'll deal, when you take Calc 3 with my wife a year from now, you'll deal with double integrals and triple integrals. And then you'll deal with double integrals in polar form, triple integrals in spherical form, all sorts of good stuff, whatever all that means. But the way that would look, I don't know if the calculator will do this or not. You would have math, function integral. Let's say we're going from 0 to 1. And then you would need another integral. I doubt the calculator is going to let me do this. This one goes from 0 to 2 maybe. Let's say it's x plus y. Where's y on my screen? There it is. And then you would have a d. You might have dy first. You might have dx first, depending on the problem. But my guess is my calculator is going to say you can't do that. Yeah, illegal nest. Double integrals, unfortunately.
So you just got to do it all by hand.
You get to do it all by hand. Yeah. It's a good time. Good time had by all.
doesn't that mean you have to take, like, the antiderivative of 2x?
Well, what it means is you have to take the antiderivative of x plus y, plug in the numbers for y, and then whatever answer you get, you have to take the antiderivative again, and then plug in the numbers for x. And then, like I say, you will also deal with something called triple integrals. So you'll have an x, a y, and a z. Or you'll do it in spherical coordinates. You'll have a r, rho, and theta. Whatever rho and theta are. Rho is just another angle. It's a Greek letter. Looks like P.
Yeah, that's
Rho. Looks like that. Looks like a
Does that
P.
make sense? Row.
That's what row looks like. All right, so the other thing we have to talk about in this section is surface area. What do I mean by surface area?
If we were to take that stuff we've been making and just find the surface.
Correct. If we were to take the stuff we've been making, like let's say we built this pen, the surface area would mean how much paint would it take to cover the outside of the pen. We've been finding volume, which means how much stuff can you put inside the pen. Surface area means how much does it take to paint the outside. All right, so it's the same kind of idea. We're going to draw ourselves a function here, and we're going to split it into tiny little pieces. So once again, let's just say we take a look at one little piece. So one little piece would look like this. Now consider if I took that one little piece and I spun it around the x-axis. What would I get? Well, I would get a three-dimensional surface. That's true. What would it look like? Not really a cylinder. You'd have kind of a big circle. Kind of like the opening to a funnel, because you'd have a big circle on this end, and you'd have a smaller circle on this end, and it would be kind of slanted in between, wouldn't it? So it would look kind of like a, you would have this here, and on the other end you'd have that, same mirror shape, and you'd have a circle here, and you'd have a circle there. This is why I don't teach Calc 3, because I can't draw three-dimensional pictures. But you would have something that looks like that. But what I want to find is I want to find the surface area. I want to find the area of this outside of it. How do you do that? You take the arc length and spin it. So you take the arc length and multiply it by something. Not pi. Not 2 pi, but you can closer. 2 pi r. What's r? The average radius. So you would find the average height in between. You'd multiply by 2 pi r. So you'd have the arc length times basically the circumference, 2 pi r. But what's r here?
When you add up the
r is just the f of x. R is the function height, isn't it? Okay. So our formula for surface area. It's going to be 2 pi times the integral. The integral means we're going to build an infinite number of these little things and we're going to add them all up. The integral from a to b of our radius, but our radius is f of x, times our arc length. How do we find arc length? Square root of 1 plus the derivative squared dx. So there's your formula for surface area. Very, very similar to the formula for arc length. The only difference is you have a 2 pi f of x. Otherwise, the formulas are exactly the same.
Problems on the test of heaters, it's going to be like the same when we find surface area using dishes and washing shelves, right? We don't actually have to compute anything, just set it up.
No. You're going to set it up and you're going to compute it. How are you going to compute it?
Calculator.
You're going to use your calculator. So if you think the problems have to be rigged to work nicely for arc length, they got to be twice as rigged to work for surface area because you got this f of x thing sitting out front. All right, so let's just try one of those. This is what it's going to look like on your test. Give me a nice function. Anybody got a good function? F of x equals sine x. And what's our interval? 0 to pi. All right, so our formula for arc length, or for surface area, it would be 2 pi, the integral from 0 to pi of f of x. What's f of x? Sine x times the square root of 1 plus, what's the derivative of sine? Cosine, so it's going to be cosine squared x dx. Go ahead.
You turn that into sine squared, didn't you?
Unfortunately, 1 minus cosine squared turns into sine squared. 1 plus cosine squared doesn't turn into anything nice, unfortunately. But it's close. You're right. It's very, very close. U substitution almost works. You could let u be cosine, because the derivative of cosine would be sine, but unfortunately you would, negative sine, unfortunately you would still have square root of 1 plus u squared. And that's not one that we can do. Again, that's a trig substitution problem. So again, this one actually can be worked out by hand.
Can you take a second u substitution?
Yes, sometimes you do have to do multiple u substitutions. Wouldn't work for this problem though, unfortunately. So again, what you're going to do, you're going to grab your favorite calculator and you're going to type in 2 pi times math function integral. And again, if you have the old calculator system, I think you're going to have to do the function integral first, get that number, and then tell your calculator to multiply by 2 pi. But I think with the new system, I can do it all in one. We're going to go from 0. We're going to stop at pi. We're going to have sine x times the square root of 1 plus cosine x squared. Now here's one thing I don't like about the new system. My screen scrolls. So it's hard for me to tell, do I have the right number of parentheses or not? I'm not sure. I'll find out in a minute. I'll just go over here and put a dx here. If my parentheses don't match, the calculator will tell me that I made an error. If they do match, it'll give me a number. Thinking. It gave me a number. I guess I had them right. 14.42. Uh-oh. You didn't get the same answer? Well, let's see if I have mine right. 2 pi.
I got that.
You got that? Okay. You did second enter and brought up the last thing you typed up and add 4x squared in there.
Well, I forgot to change 4x squared from
Okay, so when you go to take your test on Monday, I hope you will agree with me that the arc length problem and the surface area problem should be very easy ones. What's the only thing you need? You need to know the formulas. They will not be given to you. So you need to memorize them. The good news is, if you memorize the surface area formula, you know the arc length formula. You just knock off the f of x and you knock off the 2 pi. So if you know one of them, you really know the other one. They're very, very similar, very interrelated. Questions? So that should be a free 20 points for everybody right there. Last question. What if we had something that looked like this? So we had some x equals g of y, and I wanted to spin around the y-axis. Oh, we can. How would my formulas change? Okay, I would have integral, I would have dy on the end, if I'm doing arc length. What would I have on the inside? Square root of 1 plus g prime of y squared. So you can spin around the y-axis. In order to spin around the y-axis, you just simply have to convert everything to y's and then use the same formula. My interval would be from my high y number to my low y number, whatever those are. So typically they're still written as a to b, but now they're y numbers, not the x numbers. And what if I wanted to do surface area? I'd put a 2 pi and I'd put a g of y. So again, spinning around the y-axis is okay. You just have to convert everything to y's. Not so bad. What's that? But that's okay. When you go to type it into your calculator, you just use the letter x everywhere instead of using the letter y. The calculator doesn't know that you really want y's, not x's. You just tell it x's. Lie to it. It'll be okay.